Good day. Well, today's video is going to focus on joining data through a table feature in a spatial. This is a follow-up for what we went over in class. Going to be kind of an introduction to the assignment itself, so there's a basis to work from. With that, we have two main different types of joins you can do in ArcGIS Pro. With that, we have a table. So we have another, say, Excel sheet, CSV, table data itself that we want to join to a spatial boundary file. Then we can also have two separate spatial layers that we can potentially join together as well. With that, we're going to start with the first one here, and you can see we're going to be using Social Explorer, census data from the county level across the United States. Going to merge those together, join them in ArcGIS, go over how to just display it a couple different ways. And then we'll go into a spatial join using data from the Department of Homeland Security HIFLD website, grabbing the child care centers up there. Those are point level. So with that, I'm going to open up a new screen and just go to Social Explorer. And I will add a video. I'm going to move this one to the side so I can follow along. I will add a video of how to use the advanced data part to the census. It's there. It's helpful. Social Explorer honestly is just easier to use and go through to download data than the advanced census data portal. Used to have some good ones, but it's just changed over the years. But I will make some to walk through how to download the data in there as well, since that's publicly available. And this one has a paywall to get into it. With that, if I'm in tables, I want to go into the 2021, and we're going to use 5-year estimates. We're going to begin the report. So what I had students do is grab all counties in the entire United States, grab the total population, unemployed, and median household income. So geographic type, specify that we want a county. We want all counties itself, so we can just add that to our geography selection. And we want to proceed to tables. This will now allow us to select out what variables that we want to include. So total population, we want unemployed. With that, should be good. Here we go. So the rate of unemployment, labor force for 16 years and older, add that. And the last one was median household income. There we are. So we have our 3 variables of interest. We specified what unit of analysis we wanted at. That's at the county level in the United States. Hit show results, and you can see here what it's going to look like if we kick it out and download it. With that, we've done this before. Head up to data download. We want to grab %, and we also want the first label for it. It'll already have the geographic identifiers that we need, so we're fine there. Come down to download it. It's going to download it as a CSV. Specify where you want to save it. I'm going to make a new folder, Week 9 in class. And this is going to be county ACS in class. Open this up, and keep in mind, it's not going to be clean out of the gate, so you're going to have to go through and clean this data set up. With that, you can see we have a lot of blank columns. It's easy to start there to get rid of those because there's no data within those as a whole, so we can just cut those out. Same part with this second row. Remember when we add in the labels, that first row here actually gives us more descriptive labels. So I'm going to start by just clearing out the blank columns. And now I'll delete the second row. A couple more blank ones. Space it out. And you'll see now you have some identifiable information within it. So we don't need the file identification, the ACS summary file. It does give our state abbreviation. So this can be helpful if you want to select out at this point. It does have Puerto Rico in it as well. So you can come in and DC. So you can go in if you want and take those out. But for now, we're okay for what we're doing. I'm going to download or delete these 3 here. And I want to bring up an important point here. And this is where in class, a lot of questions came about of how do you join this into the spatial file? Because when we download that, I'll open it up. Essentially, you need a unique identifier across both data sets. With that, since these are census files itself, so the government manages these, we have a state FIPS code. That should be 2 digits. We also have the county within each state also has a up to 3-digit numeric digit number to it. So if we take any one of these, and this is where it's a good example of any of the first 9 states should be 01 instead of just 1, and same with the county of residence itself. So this FIPS code over here, even though it looks right, is actually missing the leading 0. So if I scroll down to where we get into double digits. You can see 16, 16, and it's appearing correctly. With that, the leading zeros cut off when we download it, so that becomes an issue. On the walkthrough in class, I say to use the right text pullout or extraction point. So when I say that, I'm going to insert a column. I see this geographic identifier here. This one actually has the leading zero in. We ideally could just use that. All you have to do is tell Excel that you want to select out those 5 right characters and pull it into a new column for you. So to do that, I'm just going to label this one GeoID. In Excel, it's truly, just have to type in right correctly. You're specifying what you want to pull from. So I want to pull from this unique value here. I want to pull the 5 right numeric characters. So if I put 5 here, it's going to grab 01001. If I said 3, it would be 001. If I said 1, it would just be that 1 at the end. So I specify I want the 5 right characters, hit enter. And you can now see that I have those 5, so the unique identifier that I'll be able to use in the spatial file. And I'll show you what this looks like in the spatial file, because we'll go through how to download that. With that, before I take it into GIS, I like to copy and paste this column. So since I have a formula underneath, and you can see it up here where it still has the right formula, I want to copy, and I want to paste this as values. This is going to keep and retain the value and get rid of the formula, so this will make it easier going forward. With that, for now, I'm not interested in the state FIPS or the county because I already have that information. This one's still a blank one, and I'm just going to rename some of these at the end so it's a bit easier to follow. So total population here, I'm just going to shorten. This is the actual labor force, unemployed, and I'm deleting over until it says the unemployed percentage because I checked that box itself. So I'm just going to do unemployed percent. For median household income, it is a longer statement, so I usually just do MHHI, median household income. That helps me recognize what it is, and it's a smaller data set now that I can easily work with. You can rename these at any point since you're going to be using them in GIS. Just make sure you're comfortable with what they are and you can remember that. So if you want to do state abbrev, plenty of options. So I'm going to save this, and it's still saved as a CSV. I did not change it over to a workbook. You can do that if you want to. And keep in mind when you open GIS, you'll just have to specify you want this specific sheet. With that now though, if I were to go into GIS and start a new project, and if I do this week 9 in class, I'm going to specify where I want to save this project folder. Courses, spatial, week 9 in class, hit OK, and we're good to go there. If I were to just bring in this table that I created in Excel, and I can exit out of it, add data, I'm going to specify where I want it, so that's still in my week 9, and let's bring in that sheet. So the sheet of data is here, so we could use this, we can see it. But the only issue is you brought in a table that doesn't have any geographic reference, so no spatial reference to it. So this is where you have to join this to a spatial layer so you can pull in your unemployment, your total population, median household income. You need to join this to another file. So that's where you have to go through and identify a shapefile to use. So with that, I'm just opening up Google. If you were at Google, you can type in census shapefile. You can see I've typed it in before, county. And it's going to bring up, and you want to see the one at the top here, Tiger Line Shapefiles by the Census Bureau. Click on here, and it's an interactive online web portal that you can use. You don't have to specify the year here, even though I ask in kind of the walkthrough to use 2020. If you click on the year, you want to use the web interface for now. And then you still have to reselect the year, even though you just did. And you come down, it's like layer type, and this is where you have different layer types, and we'll go through these as the semester progresses. It's different boundary files or features in terms of roads itself, and we'll get into that when it comes to geocoding. But for our purposes, we are interested in counties. Click on submit, go ahead and download, and you'll have to unzip this file itself. So I'm good with it saving there. Going to open up that folder. So it's still downloading, you can see it in the bottom left, my computer's being a little slow this morning, even though it is a relatively large file. Keep in mind it's all counties across the United States, including the territories itself. It's almost there. All right, so if we have this file, we can right click and hit extract all, and I'm saving it within the same folder. Good to go there. I'll keep this open because I'll probably need it here in a second. But now we have a spatial file that we downloaded. We need to add that in. So I'm going to come back to the Week9 folder. You might look in this folder and think, well, shit, I just downloaded this data, I extracted it, it's not showing up in my folder. Keep in mind you've had ArcPro open, so you need to refresh to let ArcPro know that you actually made, file changes in the background. So to do that, depending on what type of computer you're on, F5 typically will refresh the screen for you. So I hit F5 and now you can see that county file here. I'm going to bring in this layer file. So now you can see, I'm just zooming in with my scroll, that we have counties in the United States. If I open this attribute table here, you can see what consists within this file itself. It has a similar GeoID, so it has unique identifiers across, so we can see the same names are matching up here. So we know we're in the right place. So now we know across our table data here, we have a GeoID, and now in this spatial boundary file from the census, we also have the same GeoID. This is what we want to join these two separate files on to connect them. We can make now a spatial file that has rich data from the ACS. So to do that, I want to join data to our spatial boundary file. So I'm going to right click on this one, come down and join and relates, and we want to add a join. Since it is a table, pay attention to this of the next one we'll do is a spatial join, and that one will have multiple spatial layers. This one's a joined table to a spatial file. And this one was pretty good on terms of it selected the unique identifier that was common across both. It does have a warning up here for it. But if it didn't have anything, if it was blank, you would want to come in and specify its GeoID. If you name them separate, so say I didn't name it GeoID in the Excel file, you want to specify what is that unique identifier across both files itself. We're good there. You can always hit validate to see how many do cross-reference or the same. You can see here the difference of the two files. So we hit OK now. And you saw this table can almost do a refresh itself. So if I scroll to the right, you now can see towards the end, we have that table data itself, total population, unemployed, median household income attached to our spatial file. So now if I wanted to display this to see what it looked like, I'm already in Symbology, it has it open, but if it wasn't, come over here, just double click on the green box here, change this to graduated color. And with this one, it's going to default to one of the first ones. If you're working with some type of boundary file from the census, the land one is oftentimes the first one. We just want to specify one of the files that or the variables that we just added to it. So let's do median household income at the county level. It does natural break strings as a default, where that's looking for natural breaks in your data to display it based on that. You can change this based on a number of different ways. You can actually go in and change the actual values yourself. So if you think here, if I changed it to quantile and then changed it to 10, each color in here would represent 10% in that regards. You can change the color scheme, and this gives you a lot more power than Excel does. And for me, since this is median household income, I want to change where the top is going to be green and even the upper value, so I can reverse the values. I'm just right-clicking on any one of these and reversing that. The cool part is, and when you get into the legend and the final map and making the final map, you can actually change the labels in here. So if I want to say top 10%, I can change this actual label, and you can see over in the table of contents, that's updating as well. And I can change the other ones. I can delete them as I go down. All that does is change the actual label itself. So now if I added a legend to a final map, this is how it would display. You can see here, we have quite a bit of variation in median household income in the United States. You can zoom out, we still have Alaska and Hawaii down here too. Puerto Rico does not have this measure, as you can see. But for the contiguous United States, it gives you a good image of the difference in median household income based on where we are. You can see this area in here. This is Arkansas, and this lighter green one is Washington County, where University of Arkansas is, where I'm at currently recording this video. And right above that, we have Benton County, home to Walmart, J.B. Hunt, and Tyson. So not surprising you see kind of that influx here. You can see around Central Arkansas, for those in my class, we have Little Rock here in Pulaski County. With that though, it does show variation based on where you reside for median household income. You can see quite a variation here. We can get into standard deviations and ranges and everything with that. For our purposes today, we're not getting heavily into that, but we will in the later semester of running some statistics, getting some descriptives on some of these measures to be able to talk about those, and that's where you can work into your infographics. So for this one, this is where I would say you can make a final map. If you wanted to select out a specific state, you could do that. If you wanted to do the contiguous United States, you could do that. That's where we go back and use our select by attributes. Remember that every state in here has a unique identifier. So if I wanted to select out just Arkansas, I can do where the state FIPS, STFP, is equal to, and even if you ask, these are the unique values, I know it's 5. You could Google what are the census state FIPS, and it will give you a list of which one equates to what. If I did 5, I'm just familiar with what Arkansas is. You can say I now have the 75 counties, and we can see the 75 are selected in Arkansas, to where I could right click, export these out, and save this as a separate layer. So I could do AR counties only. Now when I export that and turn this layer off, you can see I'm just left with a subset of counties. And if I open this attribute table, the cool part is, if I scroll to the right, it has that data attached to it. So you join that data, and when I exported a new layer, it saved it with it. So that's always handy to use. So with that, we've done the first part of an example table join. The other type of join that you can do is also known as a spatial join. So to do that, I'm going to keep on our county layer, hit clear so we don't have anything selected. But for this one, it's asking you to go grab point level data for childcare facilities or centers across the entire United States. So to do that, we want to go to the HIFLD website, and DHS manages this. If you're not familiar with it, it's a pretty good one to get comfortable with. And you can see I've already kind of looked at this, but it's childcare centers. And you'll see here, and it gives you the warning that there's too many. So if you were to zoom in on an area, it's all points across the United States of where they're located. For our purposes, we don't want to filter at this point. We just want to download all of those points, all 132,000 of them. I'm going to download it as a shapefile though, so we can open it directly into ArcPro. Save it here, and as you can see, it's a zip folder. Just get in the habit of when you have a zip folder, come in, extract all, save it to where you're comfortable with. And now I can exit out of this. I have the data that I need. And here we want to add data back in. Come back to our week 9. Again, it's not appearing for us, so we have to refresh our folder, F5. We now have the childcare centers. Bring those in, and now you see 132,000 points on your map, even in Puerto Rico. So it does include a lot of different areas here. Now with that, say you're interested to understand and identify how many there are per county. So you'd want a count of how many childcare facilities there are in any given county. With that, as we zoom in, and I'm just zooming on a random area, you can see that the points fall within a county. So if you think about a point within a polygon, with this, you're going to want to join the points to the larger area. So you want a count of how many points there are within the polygon, or how many points does that polygon contain, so the county boundary itself. To do that, we want to join the data to our county level file that we also join the table data to. So with that, I'm going to right click on the county file, come down to join and relate again. This time it's adding a spatial join. With that, you want to specify what you want to join to this. So we still have our county layer, and I want to join the childcare centers to that. You could do intersect, but for me, I want to do contains, because each polygon, each county boundary contains different points. So think about it when you look at these different options of what you're trying to do with your features itself. We're good there. Good there. Join features fields. We're good there. Click OK. Open the attribute table. And it added just one to each, which I did it backwards. Oh no, there it is. So in the lab, you have the option to export as a new layer, and the join counts at the beginning. Here you can see it did it at the end. And this information, and we'll get into how to delete this as we go on. I just want to get into the join count itself. So this we can go through and we'll show this post spring break because we'll have to do a refresher anyways. It creates a field for you with a join count. This one is truly a count of how many there are per county within any given one in the United States. The information after it, so the name, the address of a specific childcare facility, is based on the, like if it was only one, that's the one here. If it has 182, it's likely going to be the first one. This information is not as important to us. We're interested in the count itself, how many were within it. You can see our high and low. We have some with 0, some up to 3,500, and I'm guessing that's probably gonna be around California. Turn off that layer. Yep. You can see here Los Angeles County has the most, not shocking given our population hubs itself. So with that, we also now have new data that we can map based on this join itself. So say I wanted to see a different map for the number of childcare facilities. I still have my symbology open. I can just update this to be that join count option. It's still within the top, it's in quantile 10, so 10% areas. You can see where our population is honestly probably less dense as well. You have fewer in this area. And in our main metropolitan, more urban areas, you see an uptick in the green color here to reflect that as well. Two quick ways of how to join data. Mine's a little different than if you're working on a lab computer when I did the spatial join. The spatial join in the lab lets you specify a new layer that you're going to save it at and generates a new layer for you. Mine just added it to it here. If I wanted to export this as a new layer, I could do that and it's going to save everything to it. To where if I want to save this as counties, ACS, childcare. So I added 2 different layers to it. And the cool part is if you wanted to delete fields, so say I didn't want all those at the end, if I come in here and I don't want the shape length, subtype, because I know this information, everything to me here is not needed. I just need that join count. So I can delete all of these because it's not as useful for me. And I click OK here. Now in this new file here that it just opened, if I open the attribute table and scroll to the right, I'm left with just the join count. And here we'll get into creating new variables, how to relabel them, everything to that. For now, I just want you to get in the habit of how to join data and thinking through that process. We can work as the semester progresses on how to relabel some of these, how to create calculations within this field, still getting you used to it as a whole. When I say calculating statistics, and this is if you're still watching the video, and I imagine few people are, at this point, if I just open that Arkansas Counties one that I made, I'm just going to show you what this looks like. So I'm going to open this attribute table again and say I'm interested in truly the descriptive statistics for, let's do median household income. It gives you the option here to, I just right clicked on this column and come down to statistics, let it run, and you can see here we have our descriptive statistics. Mean and median are actually pretty in line with each other, so not terrible distribution there in terms of skewness to the data set as a whole. It tells you how many counties there are, so 75, how many nulls, the minimum, so we have 29,000 is our minimum median household income with our maximum of just over 76,000. The sum are skewness values. We have a fair amount of kurtosis here, and it shows you what this looks like graphically as well across different values. So it's a nice way to understand descriptive statistics. We look at these. Some of you have probably taken social data and analysis, some of you have not, but it is a good way to get comfortable with looking at statistics. So if we wanted to select out some of our high ones here, we can go into our attribute table and look at what some of these look like. Or if I select, I'm going to zoom in on Arkansas a little bit. If I were to select this one here, it highlights it on the map for you. So it's really cool and interactive to see where the high and low ones are. So these have 5 different ones in this bin, a little over 5, so I can't tell if that's 6 there. 6, yeah, selected features. So you can see where some of the lower median household income is, and this is our Mississippi Delta area, the region itself, which is known to be more economically disadvantaged comparatively. And you can see here the middle area around the mean. You can see our mean line here. You can also turn on the median line as well. And the standard deviations around this, so plus minus 1 standard deviations, we can get into that, which if we look at plus minus 1 standard deviation, we're looking at 68% of our counties as a whole. If you haven't taken general stats, this might be over your head, but I have other videos on that from when I've taught stats in the past. Feel free to reach out. But this gives you an idea of how to join data. The next couple videos I do will be on using the census data portal, pulling some of that in and walking through how to do some of this in Excel before you get into GIS. With that, take care.